I am Anil Kumar. Welcome to my series on quadratic functions. In this video, we will understand a very important form of quadratic functions which is normally forgotten. We call it partially factored form. And this is indeed the best method to find the vertex of a parabola, especially when the equation is given in the standard form. Now that is kind of very important to understand. We'll take a few examples which are shown here to illustrate. Let us get into the basic concepts first. So let's understand what is this partially factored form. So if I am given equation of a quadratic function as ax squared plus bx plus c, this is the standard form, right? You may or may not be in a position to factor this. However, we can always partially factor. Partially factor means at least from these two, I can take ax as common, right? So first two terms, taking ax common, we will get here x and here we'll get b divided by a plus c. Now this particular equation which we have got is the partially factored form. So this is what we call as partially factored form. We'll now understand its significance. So let me further take an example to illustrate what we are trying to figure out in this particular video. So let me draw a parabola here. We'll just take a general parabola, which is, let us say, opening downwards, kind of represented by such an equation, right? So let's say we have a parabola which is kind of like this. Now, if you are given a factored form, then this point here will be represented by c. Do you see that? If x is 0, in that case, this point is c, correct? Now, if I extend or draw a horizontal line, which is y equals to c, so this line is y equals to c, it will intersect at another point on the parabola, provided it is not a vertex, right? Provided c is not equal to 0. In that case, it will intercept another point here where it is again c. Do you see that? As per this equation, this point here will be minus b by a. Do you see that part? So what do you notice here is that for x equals to 0, y equals to c, and for x equals to minus b by a, y equals to c. So for both these values, y is c. Now, we got 2 points and we call this as image point. So this point here, which is, this is the y-intercept, right? The other point here will be treated as the image of y-intercept. We will only refer this as image in general since it is being used so many times. Perfect. Now, where is the axis? How do you find the axis of this parabola? Well, right in the middle, if I draw a line so that it divides this point, right? So this point equally, that becomes the axis. So this point here is the axis. Now for the axis, the equation will be what? Definitely, it will be x equals to half of this, means 0 plus b by 2 over b over a by 2, right? So this will be equal to minus b over 2a. right? So minus b over a will give us this as 0. And if I take this value, we'll get the equation of the axis. Well, if you look at negative, definitely this is not negative if it is on the right side. But with the correct values, you will get the right answer. But you have to understand the concept first. So if I have y-intercept, I could get the image of the y-intercept. And midway between these 2 points is the axis. And once we know the axis, then the value of the function at this point, so at x equals to this point, we have the vertex. Do you see that? Correct? So we're going to use this concept to find the vertex for all the 4 equations given in this equation. Perfect? And we are going to use these terms. That is, now with the example, the question here is, find direction of opening, which you can clearly see from leading coefficient. If it is negative, the direction is downwards as shown here. And if it is positive, it opens upwards. Y-intercept, which is the last value, the y-intercept. Image point, and that is to say, when we partially factor this, we'll get the image point. And once we get the image point, we can calculate the vertex. See how easy it is with the help of these examples. Now let's take them one by one. So we have the very first very popular equation, h of t equals to minus 5t square plus 20t plus 6t. Now this equation, h of t, I could partially factor the first 2 terms. Taking minus 5t common, what do I get? I'm left with t here, negative 20 divided by 5 is 4, plus 60. What does that tell you? Let's try to understand once again. This really tells you that the graph is something like this for this equation. Normally, we are saying t is greater than 0. So let us say we'll just draw like this, right? So it's a parabolic path for a trajectory. Okay. Now from this given condition, we can say that the y-intercept here is 60. That is from where the ball is thrown, right? At 0, the height is 60 because this first term now becomes 0. T is 0, the whole thing is 0. Now same thing will also happen at t equals to 4. So this point here is 4, correct? This point here is 4. That is minus of this minus 4. So now you understand it is positive, right? And where is the axis? The axis is right midway between them, right? So which divides 0 and 4 into 2 portions. So this is at 2. So we need to now find the maximum, which becomes the vertex. So basically, we need to find what is the value of this height when t is 2. Do you see how simple it is? Substitute and get your answer, right? So we get minus 5 times 2, which is 10, and 2 minus 4 plus 60, correct? And that is 5 times 2 is minus 10, and this is minus 2. So both 20 and we get 80 as our height. Does it make sense to you? Correct? Now, I think you have seen with a real life situation, this is a very important example, you always work with this, how this partially factored form helps you to get fast solution to any application question, especially when you are given an equation in standard form. And remember, this was relatively simpler equation since you could factor this, right? Imagine if I put instead of 60 some other number like 11, right? It may become very difficult for us to work on it. Okay, now let us answer and understand the whole thing. So find the direction of opening. So it opens downwards. So one by one, let me just write down the answer. So opens down. So we can say opens down. Right, so that is first thing. Y-intercept. So y-intercept is at 0. We have 60. 60 is the y-intercept. image point. So this point here is called the image point. Now image point is at 4, right, the x value, and y value will be 60. That is the image point. Vertex, since we are doing half of 4, we get 2 here, and then substitute 2 to get the maximum, in this case 80. Since it opens down, we'll add one more. We have a maximum, right, because it opens downwards, right? Now let's take the next example. Now here, this is just for practicing. You can actually pause the video and answer this. So partially factor it, so you get 3x common. You're left with x. 42 divided by 3 is 3 goes 1 times and then 4, right? Minus 200. Correct? So this means opens up. Since this is positive, y-intercept is minus 200. That is the y-intercept. If x is 0, you're left with minus 200. Now, image point. Image point is, as you have understood, image point is what? Image point is when this factor is 0. X minus 14 will be 0 at 14, right? And what you get is minus 200. That becomes your image point. Now we need to find the vertex. So let's find the axis of symmetry first. The midway between this, that is half of this 4, right? So this axis of symmetry is x equals to 7 in this case. And to find the maximum or minimum value, in this case it is going to be minimum, we are going to substitute 7 in our equation. So we get 3 times 7 times 7 minus 14, which will be again 7, 200 minus 200. Is that clear to you? Right? So you can now multiply. 3 times 7 is 21, and times 7, which is minus. So 21 times 7 will be 147 minus 200, and we get this as minus 347. So the vertex in this case will be at 7, and the value will be minus 347. It will refer to a minimum. Do you see how simple it becomes? Perfect. So that is how we can actually easily work with standard form of quadratic equation and get all the important parameters. Here are 2 other questions for you to practice. You can actually pause the video, answer this question, and then look into my suggestions. So I hope you must have got the solution for these. Here is how I will do them. So let me just partial factor and then answer all these questions. So we have y equals to 2x is common, correct? So when 2x is common, we are left with x plus 3 here, minus 5, right? We know half of 3 is 1.5, so we need to find the value. In this case, since the leading coefficient is positive, parabola opens upwards, we do have a minimum, right? So we'll find the value of this function when x is equal to minus 3 by 2, right? Minus 3 by 2. And here we have minus 3 by 2 plus 3 minus 5. Now from our calculations so far done, you must have seen that we get almost the same thing in both these places, right? So when you do 3 minus 3 by 2, that is basically minus 1.5. You get 1.5 here, right? So you could say this is minus 3 times this is 1.5, correct? Minus 5, and that is equal to 3 times 5 is 15, 1, and then this is 4.5 negative minus 5. So you basically get minus 9.5, which is your minimum in this case, since this particular parabola will open upwards. Leading coefficient positive. Here, this is negative, so this parabola will open downwards. Is that clear to you, right? Okay. Now let's answer all the relevant questions which we need to. So first point here is direction in which it opens up. Y-intercept is -5. Image point. So image point is the point, this point, when will this x make this factor 0? -3, and we'll get -5. So image. Vertex. Now, the vertex will be right in the middle, halfway between this, right? So it is 1.5 minus 1.5. So you can write 3/2 or minus 1.5. We did all our calculation to get the answer also. This calculation may take some time. However, it is much simpler. Since these two values will always be kind of same, do you understand? Kind of same. So just square of that number is what you're looking for. Is that clear to you? Times 2, right? So it's not that difficult. Once you do a couple of times, it'll be simpler. So that is how you can get all these values. Now, the last example for you. I have taken a fraction here. So we'll write this as f of x equals to partial factor minus half and x. So you're left with x here. Since you have minus half, the sign will change. You have to now multiply, right? Divide by half is as good as multiplying by 2. So you get -6 and -2. Perfect. So as soon as you do this, you could answer all these questions. Opens, in this case, down, right? That really means you're looking for a maximum value, right? Okay. Y-intercept. Y-intercept is -2. Image point. Image is this 6 and -2. Then we have the vertex. For vertex, I have to substitute the axis. So basically, I'll first find the axis of symmetry, right? So axis will be half of this value, right? So axis will be x equals to 3. So half of this value. Now I have to substitute 3 here. So I have to find the value of the function, add 3, right? So I'm doing it in different ways so that you can choose the way you like. So we get this as -half, see, 3, and 3 minus 6, which is -3 minus 2. So it is 3 squared, that's what I meant, and that positive. So this is 3 with a negative sign, which makes this as positive. Correct? So we have +3 and then half of that. So 3 times 3 is 9, 9 over 2. So we have minus 9 over 2. And here we have -2, which is 9 over 2 is 4.5, right? So we have, sorry, this is negative, negative becoming positive. So it is 4.5 minus 2, so it is 2.5. Or you could write it in fractions also. You could write this as 5 over 2. One and the same thing. So once you get this value, you can write down the vertex. And let me now write vertex in a different ink so it's absolutely clear. So vertex will be at x equals to 3, the value is 2.5. And that is your maximum value, right? So this point here is the vertex 3 plus 2.5. So I hope that helps you to understand the concepts. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.